Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Physics Paper 2 Foundation Tier from 2022. Paper 2 is 1 hour 15 minutes long and has 7 questions and is tested on 3 main topics: forces, waves, and magnetism and electromagnetism. Question number 1. Figure 1 shows a girl bowling a ball along a 10-pin bowling lane. The girl is trying to knock down the 10 pins at the end of the bowling lane. As the ball travels along the lane, the velocity of the ball decreases. So, velocity is a vector quantity. Which statement describes a vector quantity? Now, vector quantities have magnitude and direction. Magnitude means size. Vectors have magnitude only. That's not correct. It's actually scalars that have magnitude only. Why does the velocity of the ball decrease as the ball travels along the lane? So for the velocity of the ball to decrease, something must be slowing it down. The force of gravity slows the ball down. Force of gravity is acting downwards, not on the sideways. There are no resultant forces acting on the ball. If that's correct, then the velocity would change. There is a resultant force acting on the ball. That is correct, which is mainly air resistance or friction. The ball travels along the lane at an average speed of 4.5 meters per second. So the speed is 4.5 meters per second. It takes the ball 4 seconds to travel the length of the lane. Calculate the length of the lane. Use the equation. So the distance traveled is speed, which is 4.5 times 4. That gives you 18 meters. Figure 2 shows the ball hitting one of the pins. So you have the ball which is coming in this from left to right. Let me bring that up again. So the ball is actually moving in this direction. Force of ball on the pin. Draw an arrow on figure 2 to show the arrow force. Draw an arrow on figure 2 to show the force of the pin on the ball. So now if there's a force of ball on the pin, there should be a force acting in the opposite direction according to Newton's third law, and you need to draw that as a straight line. Right, let me see if I can draw that. And the length of the arrow should be roughly be the same length. That's why they have given you 2 marks. One for the correct direction of the arrow and for the second mark for the length of the arrow. The velocity of the pin changes from 0 to 12 meters per second. It takes 0.15 seconds for the velocity to change. Calculate the acceleration of the pin. Use the equation. So change in velocity. The final velocity is 12 minus 0 divided by 0.15. That gives you 80 meters per second squared. When the pin is struck, it accelerates. Complete the sentence. Choose the answers from the box. Each answer may be used once, more than once, or not at all. So you have 3 words: decreases, increases, and stays the same. The displacement of the pin from the girl increases because it's moving away from her. So the displacement of the pin from the girl increases. The mass of the pin is not going to change, so it stays the same. The kinetic energy of the pin, once the ball hits the pin, it's going to speed up, so that also increases. That brings us to the end of question number 1. Let's have a look at question number 2. Question number 2 is on the topic of forces. Again, figure 3 shows a computer keyboard. There's a spring under each key. So this question is going to mainly be on elastic potential energy and so on. 2.1, why do the keys have springs underneath them? Well, you want the springs to come back, the keys to come back to up again when you press it. So the springs push the keys back to the original position. When you push it down, you need something to push it back up again. Why does each spring used in the keyboard have the same spring constant? So that more than one key can be pressed at the same time? Not necessarily. So that the same force is needed to press each key? Yes. So when you're pressing the keys in the keyboard, you want to apply the same force. So that the springs all have the same length? Not necessarily. Figure 4 shows one of the keys and its spring. So you can see this key here with the spring underneath it, and there's 0.004 meters of space between the key and the electrical contact switch. What happens to the length of the spring when the key is pressed? Well, the length of the spring goes down or decreases. How far must the key move before it touches the switch? So they have given it in 4 millimeters, 4 centimeters, and 4 micrometers. So what was the clearance? So 0.004 meters. If I multiply it by 1,000, I will get 4 millimeters. If I multiply it by 100, I will get 0.4 centimeters. So it's 4 millimeters. If the key is not pressed with enough force, no signal is sent to the computer. Explain why. Well, if you don't press it with enough force, then the key is not going to make contact with the, it's not going to come into contact with the electrical contact switch. So what you have is basically a metal piece at the bottom of it. And when you press it, that metal piece touches these two ends, and it allows the current to go past through this in that direction. So the spring or key will not move far enough the spring or key will not move far enough, so the electrical contact switch will not be pressed. (2.6) The spring in figure 4 has a spring constant of 400 Newton per meter. So the symbol for spring constant is K. Calculate this force on the spring when the force moves a distance of, when the key moves a distance of 0.004 meters. So they have given you the word equation. So the spring constant is 200 multiplied by this. The compression is the distance it's actually moved, and that has to be in meters. It can't be in millimeters or centimeters. So we don't really have to change that value, 0.0040, and that is 0.8 Newton. 0.8 Newton. Suggest two ways the spring in the key in figure 4 could be changed so that the switch can be closed more quickly. Well, if you want to make sure that the switch can be closed more quickly, you could use a shorter spring. So use a shorter spring, or you could use a spring which requires less force, which means you need to use a spring with lower spring constant. Use a spring with lower spring constant. That means you don't really need a lot of force. You need a force less than 0.8 newtons to push the button. That brings us to the end of question number 2, and I will see you in question number 3. Question number 3. Question number 3 is on the topic of waves. X-rays and gamma rays are types of electromagnetic waves. X-rays can be used for medical imaging. Which substance will not absorb X-rays? Now, bones absorb X-rays. Metals also absorb X-rays. It's the skin that doesn't absorb X-ray. That's why we can see through our body. Table 1 shows the effect of exposure to different doses of radiation. So dose in MSV. Now that means millisieverts. Now you don't really need to know what that this actually means. 100 effect, when you get a dose of 100, slightly increased risk of cancer. 1000, 5% increased risk of cancer. 5000, high risk of cancer. During one X-ray, a person receives a dose of 0.100 millisieverts. Why is this dose unlikely to harm the person? Well, it's much less than 100, right? So it's, in fact, if it was 100 times lower, it will be just 1. 0.1 is 1/10 of 1. So the dose is much lower than, let's say, 1%. Even slight increased risk of cancer. A doctor takes an X-ray photograph of a person. When taking the X-ray photograph, the doctor stands behind the screen. Why? Well, it's basically to protect them. As a patient, they might be exposed to just one X-ray, if they're unlucky, once a year. But as a doctor, if you are testing a lot of patients, then you are going to be exposed to X-ray way too much. So they need to protect themselves. So why would they stand behind a screen? To reduce the dose of radiation they are exposed to. Which of the following are gamma rays used for? Gamma rays are not used for cooking, thus microwaves. Energy efficient lamps are basically UV light. Sterilizing medical equipment, yes. Why are gamma rays and X-rays harmful to humans? Because they are ionizing. There's three of them. Gamma rays, X-rays, and ultraviolet are all ionizing. They are radioactive. No, they travel at the same speed of light. They do, but that doesn't mean that they're harmful. Electromagnetic waves are also used in communications. Describe how microwaves and visible light are used in communication. Well, our mobile phones work using microwaves. So, data is transmitted as microwaves which are detected by mobile phones. You could add via or through satellites. For 4 marks, for each of them, you need to describe 2 points. You need to give 2 points. So this is your first point. Data is transmitted as microwaves. And the second point is to say which are detected by mobile phones. So how do we actually use visible light in communication? Well, visible light can be sent in optical fibers to transfer information through the internet. So information is transferred as light through optical fibers or the internet. Or there's an easier one. You could say images are produced in TV to transfer information. That's the end of question number 3. Let's have a look at question number 4. Question number 4 is on the topic of forces. Figure 5 shows a distance time graph for 50 seconds of a bicycle ride. So on the x-axis is the time in seconds and the y-axis is distance in meters. So You've got the distance in meters and time in seconds. The gradient of the distance time graph gives the speed of the bicycle. Determine the speed of the bicycle. Now the gradient in maths, you'll remember gradient is y over x. Or in physics, in order to determine the speed is distance divided by the time, which is basically the gradient, because the y-axis is the distance and the x-axis is the time here. So if I take this point here right on the top, the distance is 250 and the time is 50. So 250 divided by 50 equals 5. The speed is going to be 5 meters per second. Which force acting on the moving bike is a non-contact force? Now, air resistance is a contact force because the air molecules and the surface need to be in contact. Friction is usually between two objects. Gravitational force is a non-contact force. Normal contact force, well, the name itself says it's a contact force. There's only 3 types of non-contact force that you have to remember: gravitational force, magnetic, and electrostatic. These are the 3 non-contact forces. All the other forces are contact forces. The bicycle travels a distance of 250 meters. The bicycle exerts a constant horizontal force of 30 Newton to the ground. Calculate the work done. So use the equation, the work done equals force, which is 30. So work done is, force is 30 multiplied by the distance is 250. So 30 multiplied by 250 is 7,500. And they want you to choose a unit. So 7,500, work done is measured in the unit joules. Now, if they didn't give you the unit in the box, and if you didn't remember what the unit was, you could always work out the unit from the equation. The work done is force, which is Newton, multiplied by distance, which is in meters. So the unit will be Newton meter. The bicycle travels at a constant speed. Complete the sentence. Choose the answers from the box. As the bicycle moves, work is done against what forces? Well, if you're doing work against some forces, it has to be frictional forces. So there is no change in the cyclist what store of energy? Well, because the cyclist is traveling at constant speed, there is no change in the kinetic energy. There is a decrease in the cyclist's store of energy. Well, the cyclist is spending energy, which means it's chemical energy. So there's a decrease in the cyclist's chemical energy. That brings us to the end of question number 4. Let's have a look at question number 5, which is on the topic of waves. Figure 6 shows 4 waves. The waves are drawn to the same scale. So you have A, B, C, and D. Which wave has the greatest amplitude? That would be wave A. The amplitude is basically the height of the wave. So if I draw a straight line, let's see if I can draw that again. So there we go. and so the amplitude, let's call it AMP, is basically from that point to there. That's the amplitude. So it'll be A. Which wave has the greatest frequency? Frequency is the number of waves per second. So that means the closer the waves are, the greater the frequency, which is B here. Which wave has the greatest wavelength? Now, wavelength is the length of one wave. So, wavelength, the length of one wave. Well, one wave literally looks like this, up and down. So, if starting from there to there, so that would be D, because D is only showing you one wave, which is from there to there. C, you actually have two waves there. So the answer is D. A wave has a frequency of 1500 hertz. So the frequency is 1650 hertz, and a wavelength of 0.2 meters. Calculate the wave speed. So the equation is wave speed equals frequency, which is 1650, multiplied by the wavelength, which is 0.2, and that gives me 330 meters per second. 330 meters per second. A student uses a mobile phone app that displays sound waves. Figure 7 shows the student holding the mobile phone closer to a loudspeaker. Figure 8 shows the wave pattern seen on the phone screen. So you can see the displacement, which is basically the amplitude shown here. 0.002 is half a wave. 0.04, okay. What is the period of the wave shown in figure 8? Now the wave period, which is given the symbol T, is the time for one wave. So one wave is basically going all the way up and going down, and which is, so it's starting there at 0 and it ends at 0.004. So that would be the second box. Determine the frequency of the wave in figure 8. Use the physics equation sheet. So determine the frequency. How do you determine the frequency? Well, the wave period, which is capital T, is equal to 1 over f for the frequency. So we determine that the wave period is 0.004. So 0.004 equals 1 over the frequency. So frequency equals 1 over 0.004, and that gives me 250 hertz. 250 hertz. That's the end of question number 5, and question number 6 is on the topic of magnetism and electromagnetism. Now question number 6 is exactly the same question as in question number 1 in the higher paper or higher tier paper. And question number 7 is exactly the same question, which is a 6-mark question, as question number 2 in the higher paper. Now, in this playlist, I'm going to link those 2 videos for you to have a look at rather than remaking the videos. Thanks for watching the video. Hope you found it useful. If you did, give us a thumbs up, and if you want to see more of these videos, always subscribe so that you get notifications as well. Thank you.